Students, in this segment, we shall look into the general methods of preparation of alcohols. Alcohols can be prepared from different starting material, and one among them is going to be the alkyl halide, and it is hydrolyzed by aqueous NaOH or KOH or moist silver oxide. The reagent is going to be silver hydroxide. The halide, the halogen can be a chlorine, bromine, or iodine, and the reactivity is going to be different. Alkyl iodides are more reactive than alkyl bromides and alkyl chlorides. Similarly, alkyl halide can be a primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide, or CH2X, or it could be R2CHX, secondary halide, R3CX is a tertiary halide. And if the general reaction is going to be an alkyl halide attacked by aqueous KOH, you get alcohol and potassium halide. Here the active ingredient is going to be the OH minus ion. K plus ion is a spectator ion, is inert, it's not participating in the reaction. Now if the alkyl halide happens to be a primary halide, you get the alcohol as a major product. The other extreme, if the alkyl halide happens to be a tertiary halide, you get an alkene as a major product. If alkyl halide happens to be a secondary halide, you get mixture of alcohols and alkenes. Depending on other parameters, either this could be the major product or this could be the major product. In the case of primary alkyl halide, if the halogen is replaced by the OH minus ion, and the OH minus ion is a nucleophile, therefore it is a nucleophilic substitution reaction and written as SN reaction, substitution nucleophilic. And this can be classified into SN1 and SN2. SN2 is going to be a single step process. The single step process. This is going to be the simplest mechanism, whereas SN1 is going to be a multi-step process, involving more than one step. Now let us look into the mechanism of SN2 reaction. This is a single step process. Now you have the alkyl halide, the nucleophile, namely the OH minus ion, attacks from the hindered side because it is prevented by the halide. It's also a nucleophile, this is also a nucleophile, it is going to be repelled. So naturally it cannot attack from the front side, it has to attack from the rear side or the remote side. This is the primary halide. When the OH minus ion starts approaching the carbon atom, the bond becomes weaker and weaker, the bond becomes longer and longer. At one particular stage, you have the equal distance between the OH minus and the halide. Both of them are attached. And look at the charge also. The negative charge decreases and you get the diminished negative charge. It is neutral here. So when it goes away, it starts acquiring a small negative charge here. At one particular stage, it could be 0.5, it could be 0.5. Now when the product is produced, what happens? The OH minus ion attached on the other side. So I have written as HOR. This is alcohol. And halide ion has acquired a fully negative charge, developed negative charge. In the case of SN1 reaction, this is applicable in the case of tertiary halide. There are two steps. And the OH minus ion is not going to attack initially. In the first step, the alkyl halide undergoes a cleavage, dissociation, to form alkyl carbocation and the halide ion. And that is going to be RDS, rate determining step, which is also known as slow step. And the second step, the alkyl carbocation is going to be attacked with the OH minus ion to form the alcohol. I have given two examples for these two mechanisms. It's a primary halide, iodoethane, giving rise to ethanol. 2-iodo-2-methyl propane, which is a tertiary alkyl halide, and that is when it is attacked by the OH minus ion, and that is going to give you an alkene is a major product. I told you in the case of tertiary alkyl halide, alkene is a major product. I get an alkene here as a major product, and of course a very small amount of alcohol, and that can be explained due to the dehydrogenation, deprotonation of alkyl carbocation. When alkyl carbocation eliminates a proton, you get an alcohol. There are the two options for an alkyl carbocation. Either it can be attacked by the X minus, another nucleophile, to form nucleophilic reaction, or it can undergo deprotonation to form elimination reaction. Thank you.